Section 8.5, Working with Formulas. In this section, we're going to understand the concept of a formula and recognize several common formulas. We're going to evaluate formulas for given values of variables, and then we're going to solve formulas for a specific variable in terms of the other variables in the formula. The first thing we want to look at when working with formulas is that we need to make sure we understand there is little to no flexibility between capital and small letters when they are used in formulas. A capital letter is something different than a corresponding small letter. So capital A in a formula may mean something different than a lowercase a in a formula. So it's really important that we keep that in mind as we look at various formulas. So in example 1, we're going to look at a note, and a note is a loan for a period of a year or less. We're going to look at the interest earned or paid, and we call that the simple interest. And a note involves one payment at the end of the term of the note, and that includes the principal that we borrowed and the interest. The formula that we calculate simple interest is I equals P times R times T, where the letter I stands for interest, the P stands for the principal, which is the amount that we're either going to invest or borrow. The R is our interest rate, which has to be in decimal form when we use it in our formula. So 7% becomes 0.07. And time is 1 year, or what part of the year. So if we're doing 6 months, then we would use that as 0.5 because that would be half a year. So let's look at a problem. So Maribel has loaned $5,000 to a friend for 90 days at an interest rate of 8%. How much will her friend pay her at the end of the 90 days? Well, our formula, remember, is I equals P times R times T. We're trying to figure out the total payment, so we need to figure out what the interest will be and add that to the principal that she has loaned to the friend. So our principal is $5,000. Our time is 90 days, which we're going to assume that that's going to be 3 months or a fourth of a year. Our rate is 8%, but we're going to make that 0.08. Our formula for interest would be our principal, $5,000, times our rate, 0.08, times our time, which is 1/4, or 0.25 if we want to use decimals. So now we'll go ahead and use our calculator and get our computation. So at the end of the 90 days, the friend has to pay would be the $5,000 that she borrowed plus the $100 that accumulated in interest. So the friend owes her $5,100. Now let's look at a formula that involves the difference between Celsius and Fahrenheit temperature. So we have the formula that Celsius equals 5/9 of the difference between the Fahrenheit temperature and 32. So first we want to find what C would be if F was 212, and then that's going to be A part. B part is find out what F would be if C is 20. So let's work A. C equals 5/9. We know the Fahrenheit temperature is 212. And now if we take 212 minus 32, we get 180. And then we can do 5/9 times 180, and we'll get 100 degrees. So 212 degrees Fahrenheit is the same thing as 100 degrees Celsius. Now, for part B, we know the Celsius temperature. So 20 equals 5/9 of the Fahrenheit temperature minus 32. So we have a couple ways we could solve this. The first thing we could do is we could distribute and solve that way, which is actually a little harder to solve. The other thing we could do is, because this 5/9 is times the whole quantity, F minus 32, we could multiply both sides by 9/5. And that way we can simplify the 5/9 times the 9/5, and that's going to leave just F minus 32, because these two will multiply to give me 1. And then I could do 9/5 times 20, which is going to be 36. And now to find the Fahrenheit temperature, I can add 32. So the Fahrenheit temperature would be 68 degrees. So if you're 20 degrees in Celsius, that's equivalent to 68 degrees in Fahrenheit. In example 3, we're going to look at a formula that involves the lifting force on an airplane wing. So it tells us that the lifting force exerted on an airplane wing is found by multiplying some constant K by the area of the surface of the wing and the square of the plane's velocity. So our formula becomes F equals K times AV squared. Now they tell me that the wing has an area of 120 square feet, so that's going to be A, that K is 4/3, and that it's traveling at 80 miles per hour, so that's your velocity. So if I substitute in what I know, I get F equals K is 4/3, A is 120, and then V is 80 squared. So now I can use my calculator and do the computation. So if I do 4/3 times 120 times 80 squared, I get 1,024,000. And then the unit for force is pounds. So our answer would be 1,024,000 pounds. Now we'll go back and look at a problem that uses a formula we're familiar with. The perimeter of a triangle is 38 feet. One side is 5 feet and a second side is 18 feet. How long is the third side? Well, remember that our perimeter formula is A plus B plus C when we're working with a triangle. But we know the perimeter is 38. One side is 5. It doesn't matter which variable we assign that to, so I'm just going to let it be A. A second side is 18, and we're trying to find the third side, C. So now if we solve our equation like we've done before, go ahead and combine our like terms. 5 plus 18 is 23, and then subtract 23, and we get 15 is our third side. So our third side should be 15 feet. Another common formula you'll see all the time is one that relates distance, rate, and time. We know that distance is equal to rate times time. What they want me to do in this problem is they want me to solve for t in terms of d and r. So what they're asking me to do is take this equation and let's get the t by itself. So we're going to use our same steps for solving equations, and if I wanted to isolate the t, I need to get rid of this r times t. So we've got r times t, and I want t by itself. So to get rid of the r times that, I would divide both sides by r, because r divided by r is 1. So that just becomes 1t or t, and then d divided by r doesn't simplify, so now there is my formula for time in terms of distance and rate. Now let's look at the formula V equals K over P, and we want to solve for P in terms of V and K. If we read the right-hand side as K divided by P, we could multiply both sides by P so that divided by P times P will cancel, and we get K equals P times V. But now I want to get P by itself, so I would divide both sides by V. And if I do that, I get P equals K divided by V. We looked at this problem earlier in this video. Celsius equals 5/9 Fahrenheit minus 32. So they want me to solve for F in terms of C. So if you remember the way we solved this, I said that you could do distributive property, which actually makes the problem a little harder, or we could multiply by 9/5 to start. So 5/9 times 9/5 will simplify to 1. So if I have 9/5 C equals F minus 32, we're trying to get F by itself. Well, we have a minus 32 with it. To get rid of minus 32, we would add 32. So that's going to give me that F equals 9/5 C plus 32 can't add because those are not like terms. One of them has a C and one doesn't. So we'll just leave it as 9/5 C plus 32. The next equation we have, we're going to do two different things for it. One, we're going to solve for x in terms of y. So this means get x by itself. And then the second thing we're going to do is solve for y in terms of x. You'll find in a later chapter that this is something that we will do a lot, especially this second part, solving for y in terms of x. So let's take this equation and let's solve for x. So I have 2x plus 4y equals 10. So if you remember, we get rid of anything added or subtracted first. So we're going to subtract off the 4y. We cannot take 10 minus 4y and make that 6y because the 10 is just the constant 10 and it can't combine with anything other than another constant. So I can't subtract a 4y. So we just leave it as minus 4y. The next thing we would do is we would divide both sides by 2. So I could get x equals 10 minus 4y all divided by 2. Or another way I can do that problem is on the last step, rather than dividing the entire thing by 2, I divide each individual term by 2, and I get 5 minus 2y, because I do 10 divided by 2 is 5, and 4y divided by 2 is 2y. And I could leave the answer like that. Now let's do the same thing, but solve for y this time. So 2x plus 4y equals 10. I need to get rid of this 2x that's being added, so I will subtract a 2x. And just like before, I can't take 10 minus 2x and make that 8x. I just have to leave it as 10 minus 2x. Then I'm going to divide each individual thing by 4, each term by 4. And when I do that, I get y equals 10 divided by 4. I can either use my calculator and get that in decimal, but as you'll see later, a lot of times we want to leave these in fractions. I'm going to just go ahead and leave that as 5 over 2 because 10 and 4 are both divisible by 2, minus, and then 2 over 4 would simplify to 1/2 x. And that would be my answer. So let's do another problem very similar to that. I want to solve for y. So I want to get y by itself in terms of x. So we have 3x minus y equals 15. Let's start by subtracting 3x. So negative y equals 15 minus 3x. But negative y is the same thing as negative 1y. So we'll divide everything by negative 1. And y would be negative 15. 15 divided by negative 1 is negative 15. Then negative 3 divided by negative 1 is positive 3x. So there would be my answer.